an electric fan is turned off and its angular velocity decreases uniformly from 500 revolutions per minute to 200 revolutions per minute in 4 seconds. Find the angular acceleration in revolutions per second squared and the number of revolutions by the motor in 4 second interval. How many more seconds are required for the fan to come to rest if the angular acceleration remains constant, as like in previous section part 1, calculated in part 1. So what are given here are initial angular velocity and the final angular velocity. So starting from what is given here, this is omega naught. Omega naught is 500 revolutions per minute, and converting this one into revolutions per second, 500 revolutions times divided by 60 per second, so it will be 8 point, let me, so this is 3 and this is 25, so this will give me 25 divided by 3 per second. This is giving something 8.33 revolutions per second. So this is initial velocity of electric fan. Another thing given here is final velocity, which is final velocity omega equal to 200 rev per minute. Again, this one converting into revolution per second, 200 times 60 revolution per second. So again, this is 10, this is 3, which is equal to 10 divided by 3, 3.33 revolutions per second. So these are final angular velocities and initial angular velocity. So this is final, this is initial. We have these two quantities. So other thing given here is time. The time is for 0 seconds. So it takes about 4 seconds to change the angular velocity from 500 revolutions per minute to 200 revolutions per minute. It means this fan is decelerating. The angular velocity is decreasing with time. So what is target variable here? That is alpha. You have to find angular acceleration. This is equal to what? We have several equations, rotational kinematic equations. One that is relevant for this question is omega naught plus alpha t, because we don't know alpha. Alpha t equal to omega minus omega naught, and our goal is to find alpha. So omega minus omega naught divided by t, putting into system all the values. Omega is 3.33 minus omega naught is 8.33 divided by 4. So let me calculate this one, put into system here. 3.33 minus 8.33 divided by 4. So this is giving me something negative value, which is negative value, because this value is greater than this value, so it should be negative. negative 1.25 rounding of revolution per second square. So this is value of alpha, that is acceleration, rotational acceleration. This is the first thing we have to calculate here. And second, what is the angle theta? Look at here. Let me go at the top. What is asking here is, one is acceleration in rev per second square. This should be second square. And the number of revolutions by the motor in 4 seconds. So number of revolutions means you have to find the theta, right? So theta equal to what? The relevant equation is theta equal to omega naught t plus half alpha t square. So we have everything right now. So theta is equal to omega naught is 8.33 at time 4 second plus 1 by 2 negative 1.25 and then time again is 4.00, so this is squared, so time is squared. Okay, so this is negative value, so I can put it negative sign here, so negative value. Let me put it into calculator and you get value 8.33 times 4 plus 1 by 2 negative sign, so this is subtraction. 4 squared whole divided by 2, so this is giving me theta equal to 23.27, so this is equivalent to 23.3 revolutions. So this is angle theta, or revolutions, this much revolutions. Also in part B, if I go back here, how many more seconds are required for the fan to come to rest if the angular acceleration remains constant? What do you mean by angular acceleration remains constant? Angular acceleration we calculated in first part, which is this one, right? Negative 1.25 revolutions per second. So for part B, so our angular acceleration will be negative 1.25 revolutions per second square. This should be remain constant. So finally this fan will come to the rest. That means what? Omega final angular velocity will be 0 revolutions per second, and initial angular velocity will be the final velocity of the first bird. What is the final velocity of the first bird? That is 3.33 revolutions per second. So we are using these values to calculate time. That is, how long does it take to come to the complete rest after the final velocity of the first bird, right? T equal to what? Now we again can use omega equal to omega naught plus alpha t. From here alpha t will be equal to omega minus omega naught, and again calculating t, omega minus omega naught divided by alpha. So t, which is the time required to come to the complete rest, 0 minus 3.33 divided by negative 1.25. Okay, so negative sign will be cancelled, time will be positive, which is 3.33 divided by 1.25. So putting into system, 3.33 times 1.25, so time I'm getting 2.667, so I can round it up like 2.67 seconds. So this is the time required to come to the rest. Okay, So look at here once again. uh, let me explain this problem here. Let me read it. An electric fan is turned off, right? This fan was uh, rotating rotating around axis of rotation, and it was turned off. Expect what? It will come to the rest, and its angular velocity decreases uniformly from 500 revolutions per minute to 200 revolutions per minute in 4 seconds. That's what it happened between 4 second time interval. Okay, they find the angular acceleration in revolution per second. So first goal is to find the angular acceleration, right? You have time, you have initial angular velocity and final angular velocity. Okay, we can easily use this equation right here. This is the equation, because this is connecting final angular velocity, initial angular velocity, angular acceleration, and the time period. Our goal is to find alpha. We can easily find it out because other three variables are given. And then number of revolutions. So this is theta, right? We have another equation to find the number of revolutions. So this is the equation here. Okay. From the first part, we have value of alpha, which is acceleration, rotational acceleration. Time, we already know. Initial velocity, angular velocity, we know. We can put it into this equation, plug in everything, and get this value. Okay. And then uh, in second part is asking, so how many more seconds are required for the pen? How many more seconds means after this 4 second, right? How many more seconds does it require? So when time is 4 second, spent like 4 second, the revolution, that is velocity, is this one. So this velocity will be taken, angular velocity I mean, can be taken as the initial velocity. So I'm taking initial velocity 3.33 revolutions per second. This is converting into revolution per second. Okay, originally it is given revolutions per minute, but final velocity, what will be final velocity? Final velocity will be 0. Why? Look at here. How many more seconds required for fan to come to rest? Finally, this fan will come to the rest. That's why final velocity will be 0. So how long does it take? To calculate the time period, we have again used same formula that we used at the beginning. And then also it is said that the angular acceleration remains constant as in part 1. That means we can use the angular acceleration calculated from part A. So this is the part A where we get angular acceleration. Okay, so putting all these values together here, time can be calculated, which is 2.67 seconds. Okay,